Hi everyone, welcome to this video. And this video is my final project assignment for Skyfi Lab on my ETABS course. In this video, I'm going to show how to design an earthquake resistant structure using time history method. The structure we're going to design is a reinforced concrete structure. Below is the details of the structure. The total height of the structure is 60 meters. It has 20 stories. The typical story height is 3 meters. The bottom story height is 2 meters. Since the structure is designed to resist earthquake, we've introduced a shear wall, reinforced concrete shear wall, that will help minimize the impact of the seismic loads on the structure. In the design, we're going to use the auto selector top for the beams and then for the columns. The beam cross-sectional areas was 400 by 400, 450 by 450, 400 by 500. Similar cross-sectionals are considered for the column. The slab thickness is 150 mm. The foundation type is fixed, and the building is located in India, Bangalore to be precise. The material that we're using for the beams and columns are for the rebar we are using HYST 500 and mild steel, and for the concrete we're using M40. For the slabs we're using concrete class of M30. Next is the story loads and characteristics. Some stories are similar, so have the same loads. Story 20 to 16 is considered as similar stories. Story 15 and story 10 is also considered as similar stories. Story 9 to story 5 also considered as similar stories. And story 4 to story 1 is also considered as similar stories. Therefore, in the model line, we're going to consider story 20 as a master story, story 15 as a master story, story 9 as a master story, and story 4 as a master story. All stories below these particular stories will have similar properties or characteristics as the master stories. Since we are designing the structure for India, we are using the design code IS 456-2000. That's for reinforced concrete structure, and IS 1893-2000 for seismic design. Our design procedure is as follows. First of all, we're going to create a building grid layout and characteristics of the stories. Then we define our materials. Then we define our structural element cross sections. Then we draw these elements. Then we assign our foundation. Then we define the load cases, load patterns, and load combinations. Then we assign loads to the building, that's the body load and live load and seismic loads. Then we run our structural analysis. Then we design the structural elements. Without wasting time, we can go to the ETABS software. Now we need to, from the ETABS software, before we start, we need to set the model initialization. In this design, we're using the built-in settings, the display units as metric SI. Since we are designing the structure in India, the region for default materials is set to India. The steel section database also set to India. The steel design codes, like I said, for steel, we're using the IX 800-2007 for the India. And for concrete structures, we're using design code IS 456-2000. Okay, let's click OK. When you click OK, it takes you to this template where we need to set out the layout characteristics of the structure. From the initial presentation, we can see that the structure has 6 grid lines in the x direction and another 6 in the y direction. And the spacing between each grid line is 4 meters, both in the x and y directions. So we set this, the number of grids in the x direction at 6, the number of grid lines in the y direction at 6, the spacing of grid line in the y direction as 4, in the x direction as 4, sorry, and then the y direction also as 4. Now, the number of stories is 20. And the typical story height did not change, it's 3 meters. Bottom story height is also 3 meters. Since some of the stories have similar characteristics, there's a need to use a customized story data. Here, we need to set out our master stories. So, like I said, story 20 is a master story. And then from the table, you can see that story 15 is also a master story. So we set 15 as a master story. Yes. Then we set on the table, we know that story 9 is also a master story. So we set story 9 as a master story. Right here. Yes. And then we also set story number 4 also as a master story. Story number 4 as a master story. Now, the other stories below story 20 up to story 16 should have similar properties as story 20. Now, from story 15 to story 10, all the stories there should have similar properties as story 15. So we set this to story 15, set that to story 15, set that to story 15, and this also to story 15. Now, from story number 8 to story number 6, story number 5, all have characteristics or are similar to story number 9. So we set here story number 9, we set here story number 9, we set here story number 9, and we set there story number 9. Okay? Then from story number 3 to story number 1, we'll have similar characteristics as story number 4, story number 4, and story number 4. Now, we've been able to set all stories that have similar characteristics. Now we can proceed, click OK, and then click Grid Only. Yeah, so now we have our layout of the structure. The next step is to define our materials. Define the materials, step 2. So we first of all define our concrete material. So add concrete. Now, like I said, for our beams, and columns, we're using a concrete straight of M40. So we define that first. Okay. Okay. Yeah, we did not change anything here. We move on to the concrete for slab. That's M30. Okay. We did not change anything here too. Yes. Okay. We've now finished defining the concrete materials for the beams and slabs. We move on to our rebar for the beams and columns. So you change the material type to rebar. Then the standard is Indian. Then we set this to HYST 500. That will be used for the longitudinal reinforcements. And then we add another rebar. This time we need a mouse tilt. Mouse tilt grade 250. That will be used for the confining rebar or the stirrups. Okay. Now we finished defining our rebars. So the next step is to define the cross-sectional elements for our structural elements, sections. Okay, so we come here, we go to section properties, we go to frame sections. Okay, we go to add new properties. Okay, we go to complete, and then here we define our beams first. So beam 400 by 400, and then we change the material type to M40. Okay, then we change the cross section here 400 by 400. Then we go to this tab, which is for the reinforcement scenes. The section we're defining is the beam. We need to click here. There's the design type M3 design beam only. Then we set a longitudinal bar to HYST 500. Then we set a confinement bar to 250 bar steel. Now here, we change this to 25, sorry, and this one also to 25. And then we click OK. So our first beam section is defined. We click OK. Okay. Now we want to create other beams that have the same property characteristics. Therefore, instead of creating the beam from this button, let's add new property again. We can create a copy. In this case, the beam that we are creating now would have the same material characteristics as the previous beam we've created. It's just the cross section that will change. Okay, then we click OK here. We do the same for the next cross section, beam cross section. Hard copy. So beam 500 by 500. Change the dimensions 500 by 500. Okay, that's it. Okay, now we go to add new type of we define the columns also. So column C 400 by 400. Then we change the material type to M40. Then we change the dimensions 400 by 400. Then we go to reinforcement to modify our shell rebar. Since it is a column, we design type select PM to M3 design, that's columns, and then we change our longitudinal bars to HYST 500 and confinement bar to mount steel 250. Here we keep everything here the same. We don't change everything here. Then we click OK. Now we click OK again. Now we have our first column specified. Since we want to create other columns with the same material characteristics, we can use the add copy property button. So here we enter column 450 by 450. Then we change our dimensions 450 by 450. Okay, we click OK, and that's it. Then you add another copy property. This time is C500 by 500. There's a cross section of the column by 500. 500. Okay, you click OK. Okay. Now we finished defining our columns on our beams. We need to add these columns and beams and an auto list, right, a select list. So we come here. For the property name, we say auto select beams. Okay, then we select concrete. Here, then we select all the sections that we defined for the beams. Click Art, and that's it. Click OK. So you can see here how to select the beams. List has been created. Similarly, we do that for the column. So we come here, we click here, under the property name, we type auto select columns. Okay. Then we select the concrete here. It brings all the list of the columns cross sections. Then we select all the sections. Then we click OK. And here we click OK. You can see that auto select columns is also created here. Click OK. We finish defining our beams and our columns. Now we go to define. We go to section properties. We go to slabs to define our slab. So the property name, we type in slab. 150. Then we set our material type to M30. Then we set this to 150. That's the thickness of the slab. Okay, click OK. We click OK. Now we need also to define our shear wall. So we go to define material cross section. We go to wall sections. We go to add new properties. So under the property name, we put in shear wall. Shear wall. The shear wall material type. We select entity, and then we change the thickness of the shear wall, which is let's see, shear wall is 200. So we enter 200. Yeah, 200. Okay. All right. We click OK, and then we click OK. From there, we need to go on to the next section, whereas that's to draw the elements. Now we finished defining the elements. Now we need to draw the elements. So we go back to the top software. We click draw columns. Now we set our properties to auto select columns. Okay. Then change the cross section of the columns and beams do not change with story. We can select all story here. Okay, then from here, looking at the layout from other presentations, we can select the column positions. Okay, so the first set of columns is 1, 2, 3, 4. Okay, second set of columns is the entire columns number 5. The next type of so here move to group 2, select everything on group 2, we move to grid 1, select this 4 columns, and then move here, 1, 2, select this, select that, select this, select that. Okay, here is our shear wall. Okay, that's our shear wall. So from here, we now select our beams. We draw our beams out from here. Sorry, click for beams. So click here and select the beams, and then straight and select our beams. Sorry. Okay, select this. Now draw beams. Okay. Now select the beams. Okay. Select this, and then we'll select that. We'll select that. Select that. Select that. Okay. There's one in here, so I need to delete that. Okay. Okay. We select here, select that, select that, select that. Okay. We select that, 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 that. Okay, okay, this one, that one, that one, that one, that one. Okay. Now let's draw our wall. Okay. Now let's draw our wall. Select this. We select shear wall. So our shear wall. 1, 2, 3. Okay, that's our shear wall, right? Okay. Now the beam to the shear wall, there should not be any column at this edge and at that edge, so we don't need columns there. All that we need is the beams. So click here, click on click and click here, click there, click there, click there, click there, click there, we click there, and click there. Now we have all our beams drawn. and our columns also join. I think I left this two. So we go back to beams, click here and click there. Okay. Now I think we're set. To be very sure, you can click on the street view to see whether all the beams are actually drawn. Okay, in our case, all the beams are drawn. So we move on to drawing our slabs. So here we use the quick draw flow. Then we select a slab, then 15 mm. Then we select the spaces 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, now we finish drawing our slabs. Okay, so now we can now see. Let's see the 3D view here. Shoot the 3D view. Okay. All right. So the structure is almost done. Okay. Now let's go to basement. Sorry. Since the slab or the basement is not required, we can delete that. But however, we need to set this to 1 story. So I select that and I delete them. Okay, so click delete. Delete it. That. Click delete. Okay, it's deleted. Now you select the foundation, and then you assign the support type. Fit support line. Okay. All right. Now we finish. Defining or drawing out the columns and the beams and the slabs. We've now assigned our footing type. Now we can move on to our load to define our load cases, load patterns and combinations. Now, from here, we can move to define load pattern. By default, we have dead load and live loads. And since we're also looking at seismic, we can put seismic load, okay. And then under the load type, we select seismic, and then under the auto lecture loads, we can select the Indian IS 1893-2002. Okay. Then you can click Add. From here, you can modify the load. Looking at the direction of the seismic load, we're just looking at that for the x-axis, x direction. Now, this structure, since it's in Bangalore, the zone factor is 0.1 as per the look at the IS code. Okay, the IS code. Look at the IS code, see it here. The importance factor is 1, since the structure is pre-designed for residential purpose, but the cyclic zone factor is 0.1, and the response reduction factor as per the Indian standard IS 1893-2000 is should be 4. I'm sorry, should be 3. Should be 3. Yeah. Since this is a normal reinforced concrete movement resistant frame, so you click OK here. Let's see, modify. Okay. From here, click OK. We move to define our load cases. Okay. Since we are using the time history method, we need to define the time history function. So move to define functions, time history. Then we're going to import a file. That's a time history file for an analysis that was done during the tutorials with Skyfi Labs. So from here, click Add New Functions. Then you need to browse. When you browse, you select the material, the time history data. Okay. You click Fix Assets. That's asset pattern set to 10. The headlines to skip is also set to 10, and the number of points per line set to 1. Okay, and you click OK. Okay. Now the time history data is imported. Then we go to load cases. The load cases, we click Add New Case. Under this case, we click Time History. The load case we set to Time History. Okay, select the load case types to Time History, and then apply loads applied. Select Art. Select the load type to expression, G1, and the function, we select the example time history data. And then under the scale factor, we need to calculate the scale factor using this formula, okay, where I is the importance factor, and G is ground acceleration, R is a reduction factor. Here we know the reduction factor to be 3. Okay, reduction factor is 3. Okay, since the structure is on what do we call it? Is reinforced concrete. There's a normal reinforced concrete structure. Okay, so by computing this, we have 1663.5. The importance factor here is 1. Okay, so 1 times 9.81 over 2 times 6. Okay, so this value I is input here 1663.5. We keep all other parameters same, do not change, and you click OK. You click OK here too. Then you go to define. See, modify something here. Okay, it's okay. Okay, then we define our load combinations. So in our load combination, we have default loads combinations. Let's complete keyword side and then complete screen design. Click OK. So these are the default load combinations, and click OK. Now we need to define assign the live and dead loads and the cladding loads. So we go to the story number 20. Okay. But before we do that, we need to select all stories because the dead load is the same throughout the stories. We select all stories and we select the slabs. Okay. Now we assign show loads, uniform, dead loads. So we enter 2 with the dead loads. Okay. Okay. The load loads have been assigned. Now we change to some stories and we select again story 20. In selecting story 20, it will select all stories that have similar properties to story 20. Okay, we finish selecting all the slabs. Then we go to assign, show loads, uniform. Then we change the load pattern to live loads. And then we enter 3.5 for the live loads. As per load characteristics, so live load on story 2016. And we'll click apply, click OK. Okay, then we move to story 15. Okay, and story 15. Okay, the load is live load is 4 kilonewton per meter square. So we select all the slabs on this story. As we select, it selects all the slabs beneath that have similar characteristics. Okay, the slabs selected. Then we go to assign. Click shell uniform. click live loads, and then we enter 4K linear screen. Then we click apply. So this has been applied. Click OK. Then we move on to the next set of slabs. That's story 9 to 5. So we move our arrow here at the top down to story 9. So story 9. So similarly, we select the slabs. Okay. Now the slabs have been selected. We move on to assign shell nodes, uniform, live. This time we are applying 4.5 kilonewtons. And it is good. 0.5. Okay. So click apply. Click OK. Okay, that's assigned. Then we move on to the last set of what do you call it? Slabs. That's story 4 to 1. So story 4. Do the same. Select all the slabs. Then we go to assign shell nodes uniform. And then we change the load to 5 kilonewton per meter squared. We click apply. It's applied. We click OK. Now the dead loads, live loads, and seismic loads have been defined. Then we have to assign what we call a peer label. Okay. First of all, we need to the shell will assign a peer label to the shell. Before that, you need to change this to all storage. And then we move to the ground. Sorry, story 3. And try to select the shell. Let's see if actually, let me see, select the shell. Okay, let me turn it around and see if the 3D model to see if we've got all the shell selected. Okay, alright, that means the shell has been selected. Or however, we need to first define the shell level. So we come here, define the shell level. So we're going to use the grid lines for the definition. So grid line C, grid line D, and grid line 4. Okay, so we go shell levels, grid line 4. Okay, add, modify, grid line C. Sorry, I'm going to do it capital, change, and grid line D. Grid line D. Okay. Okay, add. Okay. So now the peer level is defined. So I select my first shell wall. Then I assign a shell peer level. So I assign C for that, apply. So that has been defined. And then I select the next Select that. Okay, that was also selected. Select 4, apply. Okay, then I select the nest. Select the nest. Okay, then you assign show the rows, your labels. Okay, do apply. Okay, that's also applied. Okay, now our structure is now ready for the structural analysis. So before we do that, we need to save the structure. So we go to save. Go to the top. We label it final assignment. Assignment for Skyfi Labs. Okay. Click on save. Now the module is saved. We can now run the analysis. Okay, click on run analysis. All right. Now the structural analysis is completed. We have no errors. So now we can go and view our results. Okay, when you place your cursor over the slabs or anywhere on the model, you can see the displacements in the X, Y, and Z directions. Okay. Similarly, you can have see the blending moment. We need to toggle off. Okay, you can see the blending moments. Okay, yes, so that's the blending moment. You can also view it in the plan view. Okay, apply. Okay, so there's section A. So that's blending moments. Okay, all right. Alright. Okay, you can, if you really want to see, you can click on any member. Click on the member. We can view the moments and deflections on the shell. Okay. This can also change the load cases and look at the load combinations as well. Okay, all right. There's a lot of load combinations here that we can view. All right. So from here, you can also view. Let's change 3D. You can also view what we call the combined story response. Okay, so here you can see, you can also change this to animation. You can see the response of the story. Okay, all right. From here, you can also go to design, where you select the design with the first complex structure. And first of all, look at that the design code is correct. And then you can go to design, design, to start design. So here we need to iterate here. So you click yes. So here we click yes. Here some of the structural elements are failing, so we need to reactuate, try to use all the sections that we've defined to find which one is suitable to resist the loadings, so we can have an optimized design. All right. The frames and the beams design is okay. 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 Now let me see to check whether all elements of section has passed. Okay, all sections have passed. The design capacity check. Okay. So you can click on any element or the beams or the columns to check the design details. Okay, so that's the design. There's a column, that's the design. We can also go ahead and check the shear design, shear wall design. First of all, check the bias design code, and then we can go ahead and then start the design. Okay. All right. The the shear wall is also designed. Okay, you can see it here. All right. So that's the design. Okay. All right. Okay. We can also at the same time check the slab design. Okay, steps. You can select all the slabs except the V slab. Click OK. Alright, so that's the slab design. Okay, that's the slab design. Okay. Let's do the punch curve. Okay. Function. Okay. So similarly here, you can also select the node cases, node combinations to get the stresses in the slab. Okay. So this is a typical stress diagram in the L12 axis. Okay. You can also with the slab, you can also display the structural design. Okay, there are two methods. You can use a final element or you can use a strip method. Okay, and you're using this final elements. Okay, it will display the reinforcements at the top. We want the reinforcement at the top in the Y direction 1, or at the bottom in the direction 2. Just change it. It gives you the reinforcements required. Okay. And then the direction 2 top. Okay, that's it. And then direction 2 bottom. Loss. Right. So that's it. Okay. Now we can from here we can also generate the design reports. So you can come here. To design reports and get a report summary. So the report summary. Okay. Everything seems okay. Seems okay. We have design summary. We have the response curve structure. Can also have that. Okay. Yes. Can look at this. Can also have the display. Can also have the store response path. Okay. This store response path. Okay. Okay. So that ends the design of my G+20 building. Thank you very much.